So we're going to do this programming problem. The concept at play here is going to be pointers and arrays. And we're also going to really focus on the mindset, the attention to detail that you want to have when you're going through these problems. Half the battle is just making sure you're really understanding the instructions, every sentence, every word. So let's start reading. So we need to write a program that separates an input array into two arrays. It stores the elements that are greater than a value entered by the user in array larger, and the elements that are smaller or equal to that value in array smaller. So right off the bat, you should imagine an array, and the user is going to enter in some value, and we're going to take a look at each one of our elements and see if it's less than or equal to or greater. So if it's less than or equal to, we'll put it in some specific array called smaller. But if they're greater than that splitting value, we'll put it into some other array, larger. So just playing that out, 14 would go here. Next element is 7. That would go here. And then we would just keep playing that out, element by element. So what pops out to me there is simple for loop. A for loop that goes through each element, and maybe an if statement that says if this one is less than or equal to, put it in here, but if it's greater than this splitting value, put it in there. So it's very useful to visualize this programming stuff, because the programming concepts, for loops, arrays, if statements, they're going to jump out at you just by you just playing out the problem. And I suggest drawing it out just like I have, especially when you're first starting to learn this stuff. But the goal is, as you get better, you're going to be able to do this stuff in your head. Alright, so I think I get the main plot of this problem. And we even have a nice example situation as well. Alright, so the program should include the following function. Alright, so separate. Doesn't return anything. Or void. And looks like we have a whole bunch of inputs into this function. So let's read the rest and we'll see if we can figure out what these inputs are. And apparently we have to use pointer arithmetic, not subscripting, to visit array elements. So something like this is not allowed. We'll have to access the elements of the array using pointers. And we'll do that later. Alright, so reading here, the separate function finds the numbers that are greater than that value in array A. Okay, so that tells me that this thing right here is our input array. You may be wondering, wait, hang on. It doesn't say this. It says this. What it's expecting as our first input is an address to an integer. A pointer to an integer, you might say. Well, that's fine, because I can declare, whatever array that I want with whatever values that I want. And if I do something like this, I'll grab the very first or the 0th element, and that's all well and good. But if you just type just this, no brackets, if you just type in the name of an array, what you get is the very first address of that array. Remember, each one of these things is like its own variable. This might be at address 11, this would therefore be at address 12, 13, 14. And these are just made up addresses that I like to put down just so it'll help me visualize, using pointers. It really helps me. So that's exactly what we're going to do. We're going to send in the name of that input array as our very first parameter, because the name of any array just typed there by itself really means its base address, its very first address. Okay, as for the second input, I'm betting this is going to be the length of our input array. We need some number that tells us how many elements are in this array, so we can make a for loop run the correct number of iterations to get each element. So I'm pretty sure that is what that n is. And usually n is used as the length, either lowercase n or uppercase n. It's just a convention that programmers use. The value is that splitter value. Does that make sense? And according to this first sentence here, larger seems to be the array that will hold the values that are larger than that splitter. So I'm thinking that what we're going to need to do is, before this function is called, we're going to need to create an empty array. And we can name this array, whatever we want. But this array will be the one to hold the larger values. And we need to pass its base address as this fourth input, fourth parameter. So if this array's name was Bob, Bob would be this input right here. Okay. I don't know what size is right off the bat, so I'm going to keep reading. I'm on my second sentence here. The function finds the numbers that are smaller or equal to that value in the input array A and stores them into array smaller. Alright, so that is our last input. An empty array just like this, but this one's going to be the one that holds the smaller values than our splitter. But same exact concept. I'm going to make a second array, and that array, its name will be that last input. Alright, so this is the last input I really want to make sure I get. So, the fourth parameter size points to a variable in which the function will store the number of larger numbers in the array. Now we got to be very careful how we break this down. So the fourth parameter size points to a variable in which the function will store the number of larger numbers. So there's got to be some variable. And the purpose of this variable is to hold the number of larger elements that are bigger than this splitter. So in this case, we have 3 numbers that are bigger than our split value. So I would expect that 3 should ultimately be stored here. But we got to be careful. We're not sending this as the input. Check this out. This is expecting a memory address of an integer. This is an integer. So what I have to do is I'm going to have to send in the address of that variable. Size will point to that variable in which the function will store the number of larger numbers. So we send the address of this variable into the function. So size is just another variable, but this variable belongs to the function, whereas this variable will belong to main. Size will receive the memory address of that variable, and therefore we say that this variable points to that NumLarger variable. And through that pointer, we can change that value. And I would do this. I want to say I want to take, 7 for example, and put that in the data at address 22. Just remember how that dereference works out. By writing this, you're referring to the data at whatever address is here. So the data at address 22 is this empty cubbyhole, in which I will put a 7 apparently. So just remember your little details there. Alright, so this is just kind of scouting out the problem, but you want to be making these connections early. You don't want to leave anything to chance. You really want to nail down every single word in the question. The fourth parameter size points to a variable. So remember, read very slowly and think very slowly. Make sure everything's making perfect sense. Alright, the number of elements that are smaller than or equal to value in the array can be calculated by the number of larger numbers and the size of the input array. So what they seem to be telling me there is that the number of elements that are smaller than or equal to the splitter. So they're saying this smaller number of elements can be calculated by the number of larger ones and the size. So what I'm thinking, all they're saying there is this plus this equals the length of this. So that is obvious. I wonder why they're telling us that, but maybe it's important, will come up later. But it makes sense what they're saying. I'm not exactly sure why they're telling us that, but maybe it's an important point later. Alright, so continuing. In the main function, we ask the user to enter the length of the array elements, the value for separating the array, declare input array with the length, and 2 output arrays with the same length. The actual length will be determined by the separate function. Oh, I see what they're going for there. So here's the thing. Let's say the user enters in this array as the input array. Remember, this larger and smaller, these 2 arrays here, have to be created, because really they need to be sent in to the function here. Well, to create an array, I have to know the array's length. To create any array, I've got to know how many elements are going to be in there. Well, that's a problem. I mean, beforehand, I have no idea how many of these elements are going to be smaller or larger. So when I create these 2 arrays, really, I don't know how big they should be, which is why the question's telling us our 2 output arrays, which are these 2. They're the whole point of the problem. They allow us to split all those input elements. So those 2 output arrays will be declared with the same length as the input array. Yeah, and the actual length will be determined inside the separate function, the one that's actually going to do the dirty work of figuring out how to split this thing. Alright, so that's making sense. Alright, and the function will store the actual lengths of the arrays, storing the larger numbers. And that seems a bit weird. I don't like the wording of that. I know that we have this one variable here, which will hold the length, or how many larger elements there are. So there is a variable that will have in it how many of these guys we have. We don't have a similar variable for this one, but I do remember that with this length and with the length of this larger array, we can calculate the length of the smaller array. So there is that. Alright, so I've tried my best in sort of deciphering the problem statement. I have a good idea on the main sort of point of this thing, and they want us to have all the tough work be done in this function. I think I get that. So let's get down to the code. So first we just need code to get how many elements that input array needs to have in it. So since we're in the main function, I'll make a box that represents main, what variables are declared in it, main stack, you might say. So of course we'll have length as our first variable we're declaring. And don't forget, scanf means we're going to read one number from the keyboard, and you can't forget this right here. We have to tell the computer where exactly we're putting this number. We're putting it at the address of the length variable. So in my little model here, that'd be address 18. And let's just say that they entered in 5. So they want the input array to be of length 5 with 5 integers in it. Which means our next line of code, we just need to create that array with that length of 5. And I'm naming the array input array. It has 5 elements. And I'll just give it some dummy base address, so 50, 51, 52, and etc. Of course, there's no data in this array yet. So we'll prompt the user to enter in the 5 values in this array, which means we'll want to run scanf 5 times to get all those elements. And of course, since there won't always be 5 elements, maybe the user will run the program again and want 10 elements. We'll use a for loop. So I want a for loop that will run for 5 iterations. So of course, I will need a for loop variable, and I will initialize this variable to 0. I'll have it keep running as long as it's less than that length variable. So we'll have 0, 1 safe, 2 is safe, 3 is less than 5, 4 is less than 5, but 5 is not less than 5, so this loop will run 5 times. And of course we need it to start off at 0 so we can access that very first array element. And of course on every iteration we want to increase I by 1. And what do we want this for loop to do? Well, every time it runs we want to grab another number. Where do we want to put it? We want to put it at the address of the ith array variable. And this code will actually work for 2 situations. One, the user could, press a value, hit enter, another value, enter, another value, enter, until they hit 5 values. Or they could just enter them all as a space-separated list. And each time we run that scanf, we're grabbing one of the numbers. And actually, I think that is what the project is expecting. It seems like they want the user to enter it as a list. Alright, so I'll type that up. Alright, so now I should have some numbers in here. So let's just give it some test numbers. Alright, now we need to create those 2 arrays that are really the whole point of this. The one that will hold all the smaller elements than the value, that splitter value, which is another thing we have to do, and the one that will store the larger ones. Like the direction said, each one of these needs to be the same size as the input. So of length. So that's not too bad. And of course these arrays are empty at the moment. That function is where we're going to populate them. And we also need that splitter. Actually, that's what I'll call it. I'll call it split. So we prompt the user to enter it in. we declare that variable. So I'll give it some address. I'll give these guys some addresses too. And we scan in that number from the user and we send it to, in this case, address 70. And let's just say it was a 15. And there's one other thing we have to do, going back to our drawing table. Got the input, got the smaller, got the larger, got the splitter value. We need that variable that will hold the number of larger elements. So that's one last thing. And this thing's just going to hold how many elements are larger than that splitter. So we're not going to prompt the user for this. We just need to make sure there is a variable waiting for that value to go into it. So I'll make a new variable and I'll call it NumLarger for number of larger elements. So we have that. And of course, I'll just give that some address as well. So now that I have all that information down, we have all the information we need for this function to do its work. So I'm going to call our function down here, and we have to send it the very first address of this guy. Well, that's as easy as just typing in the name of that array. Remember, the name of an array, whether it be an array of characters, integers, or whatever, just by typing the name of that array means its very first address. So in this case, literally that would be a 50. That was our actual address. We need to send the function the length of that input array. That splitter value is the third input, and I named that split, so I'll just send that in there. We've got to send in the base address of the array that will hold the larger elements, so that will be this. We've got to send in the address of the variable that's going to hold how many larger elements there are. So, got to be careful here. I'm going to send in the address of the NumLarger variable. It would be 40. And then lastly, we want to send in the address of the other array. So A gets the address of the input array, N gets 5, the length of the input array, value receives 15, which is the split value, larger gets the base address of the array that will hold the larger values, size gets the address of basically the size, or the variable that will hold eventually the size of the larger array, and smaller gets the address of the array that will hold the smaller values. So again, A points to input array, smaller points to the smaller array, larger to the larger array, size points to the variable that will hold how many elements or how many numbers are larger than that splitter value. And we got the length of the input array, and we have the splitter value itself. So the green variables are the variables of our function. Remember, when we're inside a function, we can only use the variables that we create inside the function and the variables that are given as inputs into the function. So I got to make sure not to type out any of these white variables here. They belong to main. So now we just got to do the thing we've been waiting to do. We need to scan each one of these, and we need to make a decision regarding each one of them. Is each one less than or equal to? If so, it goes here. or if they're greater than that splitter value, it will go here. So I want to start out with a for loop that will allow us to iterate through that input array. Of course, I got to use pointers here. Well, luckily we do have a pointer that points to that very first address. So we really don't have to do an int I here. We already have our for loop variable. It's a. And actually that a is already pointing to where it needs to be pointing. So I really don't even need a first term for this for loop. Okay, and I want to keep running this for loop as long as it's less than, well, really as long as it's less than this address right here. So this would be address 51, 52, 53, 54, and 55. So as long as a is less than 55, I want to keep running. Yes, keep running. Yes, keep running. Yes, keep running. No, don't run for that one. So how do I get that 55 to come out? Well, I know how many elements there are in here, and I know my base address. 50 plus that length will get me that 55. So I was tempted to write, alright, a plus n, and that gets us the 55, but be careful. We're going to use this a variable as a variable, really, to increment through that array. So it's going to be changing, and therefore this end condition would be changing as well. No, I always want this to be a 55. So how about I create a variable and just have it store that out of bounds address here. So I'm going to move this down a bit, and I'm going to create a new variable that will store a memory address of an integer, and I'll just call it end, and the value that I want to put in here is a plus n. So that gets us that ending out of bounds address of 55. Alright, so I'm going to erase that. We want to keep going as long as this variable a here is less than this guy. And of course, on every iteration, we want to increase a by 1 so that it points to the next element's address. Alright, so that for loop gets us that a variable to run for each element and not to run for the out of bounds. So what do we want to do for each iteration of this for loop? Well, I want to test each one of these numbers. Okay, well, I got to make sure I get each one of these numbers. I'm going to take a, and I'm going to say I want the data that this address is pointing to, that this address has at it. And I want to test it. If that number, let's say, is greater than that value, that splitting value, then we want to do some stuff. What do we want to do? We want to take that element and put it in here. Alright, well, how do I put something in here? Well, I have its memory address, larger, and I want to refer to the value residing at that memory address, and I want to put in that value that I just found was larger than our split. And then of course I want to make sure that this guy increments to the next empty cubbyhole so we can put the next larger value. So after that I'll have to do increase larger by 1. Those are my pretend curly parentheses. Actually, I'm going to do the same thing here. So if a certain value is not larger than our split, therefore by default it's either going to be equal to or less than. So I can just use an else here to cover that equal to or less than condition. So else, which really means that a value is less than or equal to that splitting value. Well, we want to do something similar. We want to take that value and we want to put that into the data that smaller is pointing to. So the data at that address here. And of course, I want to plus that smaller so it can continue to point to the next address. And that'll do it. So we have a for loop that goes through each one of our guys. For each one of them, we will determine where they need to go. And the last thing is that I want to make sure that I store the total number of elements that are put in here in this variable. So really, each time we find one that's larger than the split value, we want to increase this one. It'll be 1, then 2, and then etc. So I'm going to make this code a little smaller to make room for one more statement. Alright, and I want to be able to access this variable. Well, I have its address, so I'm going to say give me the data at that address of 40. Got it. What do I want to do to it? I want to add it or increase it by 1 every time we find a value that's bigger than the split. And really, I think that's going to be it. So now we're back in main. Our function here just completed, so our code is here. And we'll assume that the function ran successfully. So if our splitter value is 15, we'd have 7 here, 17 here, 11 here, 4 here, and a 20 here. How many larger values did we find? We found 2 of them. So all we have to do is print out those smaller and larger arrays, because apparently that's what I think they wanted us to do here, print out the output arrays. So now it's going to be pretty smooth sailing. So it's pretty easy to print out the larger one, because remember, this NumLarger variable has been filled with how many elements there are to print. Now, for printing out the smaller one, there's 3 elements there. How do we get the 3? We do the length of this one, here's that length, minus the number of larger elements to get the number of smaller elements. We kind of talked about that at the opening of the problem. Because of course, the length of this guy and the length of this guy must add up to get the total input array length. So, the big thing I wanted to show here was being able to visualize how the stuff is in your program. And later concepts in learning how to program in C really require you to have this in your mind. You need to understand that main has these variables, the function will have its own variables, but of course the function's own variables, especially when you're dealing with pointers, are able to interact with the variables in main by using dereferencing. So just keeping all this stuff organized in your head is the skill you really, really want to master. Okay, hope everything made sense. If you have any questions on this problem, feel free to post them in the comments.